Hi everyone, I am Gopal and I am part of BTP's development team. So I work there as a developer and currently I'm contributing to something called the BTP's Developer Guide, which was launched last year ticket. So this developer guide is a set of guidelines which helps the BTP developers to build best enterprise grade applications following the recommendations which SFE asks the customers and partners to follow when they are building the applications on cloud. So, as part of this developer's guide in today's call, I will be talking about the observability. So, observability is something where you build the application, you deploy the application, but what's happening with the application is always unknown to us. So, with this particular session, we are going to see how do we analyze what's happening with the application and how do we fix a few things by understanding the health of the application. So, starting with the slides. So this is the session all about implementing observability in a full stack application following the BTP's developer guide. So normally when we deploy an application, it is a black box. This black box is where the app is running. We don't know what's happening within it. So if we want to make the app better, let's say uh, if there is a crash, we don't know why the crash happened. So if there are some logs coming from the customers, there might be some failures which are coming. So these observability stack helps us understand those things and help us improve the day-to operations of the application. So this is the incident management application which comes as part of the BTP's developer guide. And today we will be covering this highlighted section. So we have an app deployed in the Cloud Foundry runtime, and the app is bound to access your service persistence with the HANA. And the observability will be taken care by the SAP Cloud Logging service. So the app will be deployed to the Cloud Foundry. When we use the app, the logs will be coming to this Cloud Logging dashboard, and then we can analyze the logs and metrics and traces. In a big picture, there are a lot of components, not just logs or metrics. So we have the real users, we have the synthetic users. We also want to know as an application developer or product owners that what are the components which are being used by the application. So the real users can be monitored that way. We also have the log analysis, maybe custom telemetry where we want to see some custom metrics of the application, could be counting the number of API calls and so on. So we can really see the health of the application and these observability data following the developer's guide. And today we are going to see this highlighted sections. And for this, we are using an application called incident management and just a sample. So we don't handle real incidents. We just named it incident management. And this app is available on the GitHub, which I will show. And overall, there are multiple ways you can get started with observability. You can use the SAP Cloud ALM. The SAP Cloud Logging is something we are going to see in detail today. And then we also have a Discovery Center mission, which I will be following in order to perform these activities. So now quickly jumping into the exciting part of implementing whole thing. So I am in the Discovery Center mission, uh, which is about the observability. And if you see in this guide, we are adding observability capabilities in a CAP application. And this is the project board. So initially, when you start with a project, you will try to know like what's observability, what's the goal of the whole thing, what is the different components of this application. So to implement, the first part is obviously we get to know the use case. So here, if I open this, we have the introduction where we talk that observability is a data-driven approach which help us make informed decisions about the applications using telemetry data like logs, metrics, traces, events, and so on. And when you uh, look into these diagrams, it can also be done in the Kyma runtime where you can connect your cluster to a cloud logging instance, and then all the apps running in the cluster can also push their data to the cloud logging service. Uh, so now, once you have this introduction, I can jump to the development environment. And for this, I have used something called the uh, CapJS Incidents app. So this is the application which is coming from the BTP's developer guide. And there are tutorials like this already available. So this becomes a prerequisite for this exercise. So this is the incident app which I have already cloned in my business application studio. And you can see like this is my package JSON file with different configurations. And I can just do a CDS watch to start the application. And as a standard application, it has all the components like we have the UI, we have the database, we have the services. And the app will be now running. And let me just launch it quickly. I just give the temporary password and yeah, the app is now running. Now I will go back to the mission and the first part is about implementation. So let's say I go to the next card, uh, which is set up the incident management application. So I already have this deployed application, which followed the develop full stack app application tutorial is the one. So this is something all the steps are done already by me. So we can just focus on the observability part. So now again, going back to the mission, I go to the next card. And here, so basically, by default, CAP offers a set of logs to you when you are running the application. So if you see in the logs, I launched the application, and then there are some set of logs coming where I can see some logs are generating by CDS, some are coming from the OData. And now, if there is a failure or let's say some incident creation happening, those logs are also going to come by default. But as a developer, you will want to have some custom logs to be added in the application. So here in this example, I am going to add a log and let's say I will say that from the processor service, just a name that I'm giving, I want to generate some logs. So I come here, I will just add the logs. So now I have created a logger. Now I will just add this custom log to the application because that's and what in this log I'm doing is I'm saying that I wanted to see what incident is getting closed or the incident where I was trying to close, why it's failing. So this is just a custom example. So I just copy this custom piece of code. I can add it here and save it. Now, if I jump back to the application, let me launch it again. And the log will come when I'm trying to basically close the incident which was already closed. So going back to the application, let's say this incident is already closed. So I come here, edit it. I will try to change the urgency of it to make it low. Obviously, it doesn't make sense to close a closed incident. So it gave me a message that can't modify a closed incident. Perfect, not an issue. I discard it. Now I go to my local development environment, and if you see, this was my custom logger. The name was processor service. This is my message. So the incident ID has been logged in here, and this is coming from this service. So this is the custom log. There are other log also coming from the CAP framework, where it's giving me a stack trace also. I can also define the level of logging. So for example, uh, I want to have a debug logs for CDS, SQLite, and just info logs from CDS. I can change it. And in production, if there is a need, I can again change the log level so that we can get more debugging information. So I change the log levels and the app will run. And now we can move to the next section. So we have the custom logs and we understand that, okay, something like this is happening in the app. So the next part is where the magic starts. Now, CAP framework comes with a plugin called CapJS Telemetry. So I can open this and show you. This is the plugin. And this plugin comes with a lot of predefined kind, like uh, by default, if you enable the plugin, it will start generating a lot of metrics and traces. You really don't have to write any piece of code. So it's having more developer efficiency coming into the picture. And this plugin also helps you push your logs to console, Dynatrace, Cloud Logging, or Jaeger. Like as the requirement is, there are some destinations or endpoints where you can pass, and many more information can be seen here. So going back to the mission, so to add it, I just want to add some of the libraries in my app. So I will come back. Let's just stop the server, add these libraries, and we'll just take a few seconds to get it installed. Perfect. So I can see that in the dependencies here, the CapJS telemetry is added. So I can do a CDS watch. And as a developer, we always need to know how do I see what's happening with my app while I'm developing. So that's where the local logs or the logs during the development time is really helpful. So now the server is running. I will launch it again. Let's have the user entered here. And now let's say I want to create an incident. I will name it let's say cup broke. Any random thing basically. I choose a thing. I set a urgency to high, and let's say I also can add a conversation message. Uh, Please fix it. Create it. And if I go back to the application, so here the magic begins. All I did was I just added the library captures telemetry. Two more are there, but that's something is needed when we make it available for production for custom metrics. So with this particular plugin, you can see that I am getting a set of metrics. So the first one is I created a post request, and for that I can see a stack trace. So the overall 10 milliseconds was required for the post operation, and then you can see the different layers at which the request was processed. Now, I'm also getting other attributes like server duration for that request, the port, the status code, the method, uh, and also the DB pool. So the number of threads which are available. So right now, because the operation is completed, all threads are available. And since we are using SQLite, there is only one thread available in the DB pool. So this is the local one. Now let's go back to the telemetry. So as I said, like I added the library to the app. So now I have to also define that where should my logs, metrics, and trace should be pushed to in BTP. So I will define that it should go to the Cloud Logging service. So I go back to my app package, and I can just easily define that this is my endpoint where I want to push my data to, which is the Cloud Logging. If there is any other, we can do it also. So this is added. Now I can go back. So yeah, these are some set of things we can see in the logs. Now, this is not the only metrics which normally people will need in their application. So people might also need more details, like let's say I want to count how many incidents are open in the system which are having high urgency. Maybe there's a huge load in the app system, so I want to analyze that. So here we have added a custom code. So there is a code which I will have to add to my app for custom metrics. So let me just copy it. I will need to create a file called server.js, which is here. And I paste things here. Now, I will explain what's happening here. So I'm importing the open telemetry APIs, which are coming from the uh, CapJS telemetry plugin. Now I'm also defining a custom meter here. So I am giving it name that it's a incidence of urgency high. So it's a naming convention which I'm using. And for the meter, I'm saying that it's a up and down meter. So up and down means it can go up or down. If a new incident is there, can increase the count, and if the incident is resolved, I can reduce the count. So that's why using the up-down counter, there are many more counters which can be used. So, and you can see the details also regarding it coming in the screen, like what's the up-down counter. Now I also have few things here. So I have written a custom logic here. So for the processor service, if there is a create event on the incidence entity, you check for the urgency of it. And if the urgency is high and status is not closed, counter should increase the value by one. So I'm increasing the value by one. Similarly, if the incident is getting updated and let's say uh, the value for urgency is high and it's not created. So maybe incident was created a medium priority and now it's getting updated with high. Or if it's getting close, then I will just reduce the count value. So one. So this is something that I have added. Now it will start the server again. So let's launch it. Uh, let's create a incident with high urgency. Right. Urgency will be high. Just create it. So if you see since I added a debugger, the request came here, it will process it, and accordingly it will increase the counter. And when it increased the counter, there was a lot of activity happening in my console. So I can already see that there was a lot of telemetry events happening. And since there was a breakpoint, it took more than normal time, like around uh, 11,000 milliseconds for this post request, and there were activities happening. So I can see the stack trace, and yeah, these are the stack traces. And for the custom metrics that we have added just now, this is the value which is coming. So we had added this custom metric for the telemetry called incidence urgency high. And I can also see the tenant for which this is happening. So tenant one, which is local tenant. And the value is one because we created one incident with high uh, value or high urgency status. So when I keep on creating more and more, this value will increase to two, three, four, and we can get a number of high urgency incidents open in the system. And this is just again an example. There can be many more complex use cases where this custom metrics can be implemented. So now that this is done, I can jump back to the mission. So as of now, what all we did, so we added a custom log that helps us as a developer to understand if I want some particular information because there is a bug or something. Then we added custom metrics and traces by default coming from the telemetry. And then also we added a custom metric, which was the counter of up-down values. Now, the next part is adding the cloud logging service as a dependency to your backend. So for your MTA, existing MTA for the incident management, I just need to pass this configuration. So I say cloud logging service plan standard and just enable the ingest endpoints. So this is something I already have kept ready for the example. So if I go to the bottom, uh, I can see this is my cloud logging service. And if I just try to do a find of it, at top, I have added it as a dependency for the CAP backend, CAP SRE. So all said and done, I build it, I have the mtar and I deploy it to the Cloud Foundry and I get a incident management application running. So I just refreshed it. It will take my login and I will also refresh the dashboard till then. Okay, awesome. So you see, this is my incident management app in production deployed. So I will just create a incident here. So let's give it a thing like charger broken. I add a message. I will set urgency as high. Let's give a message also. I just want a new charger. So I will just create it here and it's created. Now incident is created, there was one more logic, custom log. So I can try to also change the urgency. So I will just edit it, change the urgency of a close incident, and I got the error. Perfect as expected. So now I have everything done from my side. So the next section is checking the logs. So I already have the app configured. The data is getting pushed to the cloud logging. So I jump to the cloud logging dashboard here. So I have opened the dashboard which talks about what's cloud logging. So I will go to CF. I also can see data from Kyma. So let's choose CF to begin with. And I can see that, there is 100% success rate of the application, response time, average response time, and so on from the incident management service. So a basic overview of the application. If I had multiple apps deployed, I will also see the boxes coming here for all the other apps, from where we are getting this data. The four golden signals, again, very critical for the applications. Now, let's say I want to, as a developer, see the requests and logs because that's going to help me understand what's happening with the app. So I can see the request logs, and there are a lot of post requests which happened. I can also see logs generated by the app. So we have the info and the error logs, can't modify a close incident. And this is a custom message which we have passed, right? So incident with the ID has already been closed. Uh, There is no runtime log because there was no activity just now. So let me just increase it to today, the duration. And I can see the runtime log also where there was some crash or the app start which was happening. So I get an overview. Now I also have a new capability coming from the cloud logging, which is app crash detection. So if the app crashes, which happened today 5 times, I can change the duration to, let's say, last hour. Maybe let's make it last 3 hours or 4 hours. And I can see there were 5 crashes during this time. Now, what I will do is I will go back to the application. Let me just log in. While it logs in, I can explain, like it also talks about like the different type of crash. So here you see the status is 137. So I can refer to it like 137 means it's a graceful shutdown, and here I can understand that, okay, uh, it's a out of memory issue. So what's happening with out of memory issue? App tried to consume more memory than the allocated quota. So to demonstrate how that can work, I have this instant service. I will just make this as 50 MB. So the Node.js app or the CAP app will need more than this to work with. So now the app will restart, and I can go back to the dashboard. Let's say make it last 15 minutes. So no data. Now the crash happens, I will start getting some data here. So it will just take a couple of minutes or seconds to reach here, and perfect. So data arrived. I can see that there is one crash. The reason is out of memory. And as a DevOps person or as a developer, I will know that, okay, it's out of memory. Quickly, I will jump back to the dashboard or increase the quota. I can make it just 500 MBs. Because I know the reason, I just start it, and then the app will be up and running, and the error will be resolved. So yeah, I can see that there was a crash during this. Now, one more capability which is there is checking the open telemetry data as part of observability. So I will just increase the span to today, and I can see that there are spans. Spans are also, we can call it as traces. So I can just click on it and it will show me a trace of this post event. And a trace helps me basically understand the different levels at which the app was taking how much time. So for example, DB read for incidents took around 10 milliseconds. The post request overall took 47 of 2 milliseconds. So this can help a performance expert to improvise the performance of their database queries. So the next part is metrics. Now, we had enabled metrics using the CapJS telemetry. And if you see, I'm getting some metrics data here. We have DB pool, resource, pool borrowed, and so on. And also the custom metrics like incident urgency high. Uh, and I choose this. And if you see, the latest value is 2. So that means there are 2 high urgency incidents open in the system after I have deployed the application. And as a DevOps guy, I can just keep eye on these data and understand what's happening with the app in terms of metrics. Now, this dashboard is pretty cool, but if I still want to go in further details, I can go to the Discover section. And here you see there are the app logs coming. A lot of logs are here. So let's say I want to see the message. And let me search for maybe app. Yeah, app name. Uh, Perfect. And maybe the logger, log level. So I can see and imply like what's happening. So there was a restart. So there are a lot of restart events here or data logs coming because of restart. So perfect, like out of memory and so on. And if I, let's say, try to create the same situation, like trying to close a incident which was already closed, let's try to change the urgency. Failed. I will go back to the dashboard. I will just click on refresh. And you can see the error was can't modify a closed incident, the incident ID. This is my custom log. And the whole set of logs regarding that event gets visible here. I can also choose to jump between logs to, let's say, metrics. And I see all the metrics also in a different way. And now the last section is about the observability. So if I go to observability, I have trace analytics. Let's increase the duration a little. And I go to the traces. I have a lot of traces. So let's pick one of it. And I can see a trace breakdown of this post request. So again, like as seen in the previous section, it can be also visualized from here. And if needed, I can go to also visualize section and let's say I can create a custom visualization of metrics or anything. So let's say I can create a visualization for this metric. I can choose metrics total V1, which is a custom metric. And then I can choose, let's say, top hit of value. Now it will take a couple of seconds, and here I can see the incidents. Urgency. So let's update it. And yeah, in couple of minutes, this dashboard will start pulling some data regarding this high urgency incidents, and I can then save this. Uh, let's say high urgency incidents. And later I can just jump here and see these incidents from the custom dashboard. So I can search for incidents with high urgency and visualize it here. So normally it takes 3 to 4 minutes to see this data appearing. Uh, so that's about the cloud logging service and observability. So now I can go back to the cards. So I deployed the app. Then the next part was if the runtime is different, like the Kyma runtime, the steps are a little different for the deployment. Then going forward, uh, this is what we have tried to show in this demo. Like you have the dashboard and everything from the logs, metrics, and traces to the custom dashboard. Like this can be visualized, and then you can use to understand what's happening with the app in terms of its health, uh, the expensive database queries and so on, and which helps making life of a developer better and easier. So now there won't be any black box where we don't know what's happening with the app. It's all transparent, and we can take actions based on these data coming from the Cloud Logging service. So that's about the hands-on, and we have this Discovery Center mission for observability where all this data can be seen. So all you have to do is come to the Discovery Center mission, search for developer guide, and you will have this set of tutorials. Like we have the full stack app following developers guide, observability, side-by-side extensions, and so on. Similarly, there is also CapJS telemetry plugin, which you can refer to learn what more capabilities are there. And also, we have this SAP samples where we have the developers guide. I can go to the documentation, and then all the different chapters which I talked about can be also visualized here. So the observability, as we talked, is here. I can go to the introduction, and yeah, the solution diagrams and whatever we saw in the mission also is visible. So that's all from my side in terms of observability, and we can have any questions that we can answer now. Yeah, that's all.